Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And this time we're going to be talking about some of the sky watching events that are going to be visible for, I think, the last week of March and the first week of April. Probably just the first week of April. It's the 31st
It's the end of March already.
Yeah, so by the time anybody hears this, it'll be April 1st. Little April Fool's episode. But no jokes, really, in this one. Yeah, I guess the things let's see, what's happened in the last couple of weeks? We had the solar eclipses, or the solar eclipse at the beginning of the month. And then 2 weeks later, we had the lunar eclipse.
Right.
We talked about that, and like the Saros cycle and the draconic months and stuff. And then now, from here on out, I think there's like a couple cool planetary things that are happening that we should keep an eye on. Definitely through like, I guess through April and then through May too. I think that's when a lot of the interesting stuff's going to be happening. When we're going to have the best viewing of Jupiter. Right now, I think is probably for us going to be the best time to get a lot of observations of Jupiter. And because it's going to be at a pretty good opposition point for us, it's going to be in the dark part of the sky almost all night. And especially like it's going to be up overhead. It's going to be, good spots to get a lot of good telescope observations of it while it's away from the lower horizon line. That's when you get a lot of dust or a lot of atmosphere in the way. If you think sort of if you go laterally, it's a lot further. It's like many, many miles to get through all of the air that would go out to get you outside of the Earth's atmosphere if you look kind of at a skewed angle toward the horizon.
Right.
It's a lot further than it is if you were just looking straight up, where it's like 75 miles and you're really, really outside of the Earth's atmosphere. But otherwise, if you're looking kind of at like a flat angle, it's really quite a bit further than it is, or it adds a lot more distortion, especially if there's convection currents. That's where we get those twinkling lights a lot of the times between, the heat and cold, hot and cold, I guess, moving against each other and then causing a lot of convection to happen with the element or the atoms that are kind of making up. Well, what would it be? Yeah, I guess the atoms that are making up the atmosphere in between us and then the end of the atmosphere. We see that kind of movement going by. A lot of the time it's like water or water vapor or hot heat kind of moving through and kind of distorting it. That's what we see a lot of the time. And so that's what we see like on a really twinkly night, or when we see like a lot of dust in the air, anything like that, it's going to impede the ability to make really clear observations. But a lot of the time too, Jupiter's so bright that we'll be able to make a good observation of it, no matter what.
Yeah, it seems like it's one of the ones that's usually pretty easy to find.
Yeah, it's really easy to find right now, especially for, like we were talking about, in April and then into May, definitely. Right now it's up. So if you're able to find Leo, you're going to be able to find Jupiter. Right now, I think that Jupiter's still in Leo. It might just be on the border, kind of moving out of Leo, but I think it's really at like the head of Leo. If I might be mistaken, I'm not sure. But yeah, definitely look up to Leo. What you're really going to probably find first is Jupiter. And then you're probably going to see Leo next to it. Because Jupiter's really bright right now. I think it's at its opposition point. It was, I think, less than a month ago at its point of opposition when it was coming up. But yeah, I think it's out in Leo right now. Probably coming up just after sunrise, or, like right as the sun sets, as the sky gets dark, we have Jupiter rising up into the sky. And so it has a pretty good transit through most of the night sky that you'd be out. So if you go out after 10, like 10, 11, 12, midnight, that's going to be really, really good time to get some observations of Jupiter. I think we were looking up a little bit earlier, like there's just a transit of the storm on Jupiter, the big red spot.
Oh, right.
There's like an eclipse of Io that you could see if you had a telescope. There's going to be an eclipse of, I think, Enceladus later this week that you might still be able to catch if you have a telescope and if you're in the right position to see it for the period that it happens. But I think that's when, Jupiter's shadow is being cast out. And so Enceladus is going to swing around in its orbit and then hit the shadow and then be eclipsed by Jupiter, fall out of our view for a period of time, and then wrap back around and drop out of the shadow back into the sunlight, and then will reappear when we're able to see it. But like we talked about with eclipses last week, the lunar eclipse happens for quite a bit longer here on Earth when we're observing a lunar eclipse. because the Earth is just so much bigger, it has such a bigger shadow than the moon does. So imagine now if we're talking about eclipses of moons from another planet and now a gas giant like Jupiter, those eclipses last quite a bit longer because those moons are so much smaller, so much more insignificant than the shadow, the large shadow that's cast by Jupiter.
That's a really cool one. That'd be neat to see the telescope. If you're in the right spot, do you know who that is going to be most visible for?
No, I'm not sure. I'm not sure how long the period is that it lasts. It's probably visible for a lot of people. And it seems like if you're, I guess I'm just kind of teasing the idea of making observations of Jupiter because really, if you're keeping an eye on it, these types of events probably happen, like every week or so because the moons are just sort of going around and,
right.
Going through their cycle of motion too. So yeah, it'd be really cool. We should definitely start making some observations of it.
We should. I want to get the telescope and
yeah, we should get the telescope in good order. And I want to work on this with you too. We hadn't talked about it before, but I want to make or do telescope observations of the moon every night during its cycle.
Oh,
or every night, at least up from new moon to full moon, and then probably a little bit past that. But we should try and do.
Really interesting.
I did it once years ago, and it was really cool. I think I did it through June, just because I had everything set up, and it's great too. I mean, now even right now, it's still kind of risky that you'd get 30 clear nights of weather to make an observation. In June, you had a bit better of a chance, so I try to do it all the time. And there's some cool things that you would learn. Some other things that I've been told before, like when you're making telescope observations of the moon, it's really not best to do it when there's a full moon. And the reason for that is because you don't get the definition to the landscape that you would if you're trying to look at the moon through a telescope at its first quarter.
Interesting.
Yeah. So the reason for that, you got to think about it a little bit, but it really makes a lot of sense. You would think that it would be best during a full moon because you can see it all, which you can see a lot of the geography. But the problem is that you're looking at the moon during its period of high noon. So if we were to think about high noon and sort of the way that the shadows look and maybe how things sort of play out on the Earth, we could kind of translate maybe what's going on the moon also. So what happens, during high noon on Earth is everything gets kind of flattened out. There's no shadows. There's not much contrast. Shadows are going almost straight down. And so what happens is you really don't have a good way to look into the definition of the moon. Since we don't really have a keen eye of the geography of the moon anyway, there's no definition in the mountain ranges that are casting shadows or the craters that would have shadows cast. But the time that we do see these cast shadows that are the definition lines that our eyes use to sort of make out and understand the geography and the geometry of the shapes that we're looking at when we're observing the moon, that's what we get to see during a first quarter moon or that half moon that we observe here from Earth, when it's halfway full of the whole size full moon. It's pretty cool stuff. It's cool getting to check it out through a telescope and getting to do it even just from new moon to crescent. You get to observe a lot of the Earth shine, which is, I think we saw a little bit of it during the new moon cycle a couple weeks ago, which we're probably going to see in just a couple days. Right now, the moon, what was it yesterday? It was
it looked like it was getting close to half.
Right? I think yesterday it's pretty close to the last quarter. I think a third quarter moon, which is like the last crescent before it comes back into the sun. And so I think they were talking about how it's in Scorpio. It's making sort of a square shape with the moon, Mars, that's now in Scorpio, Saturn, that's now in Scorpio, and then the bright red star Antares, that's in Scorpio. They're sort of like a square shape, just all concentrated in Scorpio this week, which is kind of cool. Yeah. And then outside of that, when the moon's not there, you have, like we talked about a minute ago, we have Mars and Saturn and Antares both right there in the heart of the constellation, which would be pretty cool. I think Scorpio right now probably comes up for us probably around 3 a.m. That's what I'd sort of think. What would it be? Yeah, I think it's around then. I remember, having to stay up till about 1 in the morning, even pretty late into May, to get a good viewing of Scorpio coming up on the western horizon. So I think you still have to stay up pretty much till morning to get a good observation of Scorpio up in the air. But
we should try to do that while
definitely
while it has all those things in it.
Yeah, definitely. Cool. That's the cool thing. I think it's gonna stay with those things for a little while now. So we have some Mars and Saturn in Scorpio. Saturn is moving real slow. I think it's moving year over year. What we're going to see is Saturn move from its position in Scorpio and then transit backward in a sense in our sky toward the constellation of Sagittarius. It's not in retrograde like we think of it with the other planets and stuff. It's moving real slow, and then but it'll still kind of pass down at a regular interval of time. But I think like next year, it'll probably be a little bit closer to like the tail of Scorpio or back into Sagittarius a little bit. Like remember a few years ago in 2014, we were looking at Mars and Saturn in the Alvord on our trip when we were making some observations.
Right, yeah.
And they were out in front of Scorpio a little ways.
Yeah, I remember that.
And so Saturn hasn't gone around another time. All that's happened is what we've seen is Mars go around and come back to its same position in the cycle, but this much further down in the future.
That's really interesting.
What's happened, is Saturn, since it moves so slowly, I think it's a 27-year orbit. It's moved back just a little bit. It's moved from wherever it was in Libra now to like the head of Scorpio, and then now back into the body of Scorpio. And then I think it's going to start moving a little bit faster and kind of drop back into Sagittarius, maybe by the fall. Is that what we see? Maybe I'm mixing that up with something else, but that's going to be the cool thing. So Saturn is going to be staying put pretty well. But the cool thing is that Mars is on a mission right now. It's moving around quite a bit, and it's changing a lot too, which is kind of a cool, interesting thing to make observations of, because you see just this one body stay essentially in the same spot and then move around significantly in sort of a peculiar way, at least as we'll start to observe with Mars as we kind of talk about it over the next couple of months, and then start to get dimmer and then not be as relevant anymore. But we're going to have a great set of observations this summer, like at the end of May. So right now, Mars in Scorpio is at a negative 0.51 magnitude. That's
Pretty
today.
bright.
And it's bright. Yeah, it's brighter than a first magnitude. It's brighter than a 0 magnitude. And now we're up to a negative 0.51. That's how bright the magnitude is. On April 15th, just half a month from now, 2 weeks, it's going to be at a negative 0.97. So almost a negative 1 magnitude
That's really
visible
cool.
object in the sky.
That's good for looking at.
Yeah, it'll be cool. But what's cool too is it's getting that much brighter every day. So you're going to really almost see it sort of emerge as a really bright object in the sky, which is going to be
That'll
cool.
be cool to
So
watch.
if you're staying up late enough to make observations of it in Scorpio, which is a little bit difficult right now, but it's kind of like a 2, 3, 4 a.m. sort of project. You can see the changes of Mars as it's holding position in Scorpio and then getting brighter and brighter. I think that's because we're coming in really close to each other, if I understand right. Would that make sense? Sort of three, if you're thinking third dimensionally, I think what's happening is that it's staying in Scorpio, but right now the Earth is getting closer to it physically. Like the distance between Earth and Mars is sort of shrinking the distance.
Right.
And so I think that's why it's objectively getting, or what would it be? Subjectively, from our point of view, getting brighter in the skies because it's moving closer to us. And then what we're going to see is, move to negative 1 position by the 15th of April. By the 15th of May, it's like up at a negative 2 position. So it's getting brighter and brighter and brighter, almost a whole magnitude's worth per 30-day cycle or per month, which is really cool.
That is cool.
Yeah. So by the 3rd week of May, I think we talked about this maybe on our first podcast. It's cool that it's starting to happen. On the 3rd week of May, I think Mars is going to go back. It's going to change position, go back in retrograde, and move forward in the sky really quite quickly outside. So it's going to be right up next to Saturn in the heart of Scorpio. And then it's going to move westward in the sky over just a few nights, relatively, up until like early June, into Libra, stay there, and then move back into retrograde and push eastward in the sky again, back into Scorpio, and then stay there and stay with Saturn until the fall. And then I think Mars starts to push even further back into Sagittarius and then onward until whatever the next part of the cycle is. It's really interesting. It's going to be cool to see.
Yeah, this is going to be really cool to see. It's neat that that cycle's kind of starting, or watching it move like that is kind of
Yeah, it's kind of rare that we're going to get two really bright planets doing sort of a retrograde motion at a time of the year when it's just going to be so visible for us. It's going to be the beginning of summer, late May, early June. We're going to have a lot of good observation nights, and they're going to be just really bright objects in the sky that'll be pretty simple to observe. It's going to be a lot of fun to keep an eye on it. But yeah, right now it's both in Scorpio, both pretty dim. Or I think Saturn's a bit brighter. Saturn's got a good bit of, it's visible at least, but man, Mars is going to get way brighter. I think it tops out at almost the brightness that we'd see of Jupiter right now. So like we'll go out later tonight. We should take a peek at Jupiter and see how bright it is, or just how visible and dominant it is in the sky. And Mars is going to push up to almost that same brightness here in just weeks, really.
That's going to be really cool to see it get so bright. It becomes so much more prominent.
Yeah, it's going to be interesting to see kind of how that changes in the sky. But it's always fun. I remember years ago, I think back in 2003 or 4, when Mars had its other real close pass. There's been a couple other years since then too that it's come around and gone through Scorpio. But I think back in 2004, there's a really bright period. Like it got at its closest. It was one of those things where there's a bunch of emails set around. It's the brightest you're ever going to see Mars in your lifetime, sort of a thing. And it really was. It was super bright. I think it was like in maybe like I think it was like mid-September, or maybe late August. Might have been like a late August viewing of Jupiter, sort of in the Scorpio area, and it was super bright, really dominant in like the southern sky for the summer. So it'll be really cool. I'm excited to see that kind of come around again. Have it be really bright in that sky section over there, and with the whole retrograde motion that it's going to go through at the end of May.
That's going to be really fun to look at. It'll be neat to watch and see its movement. It's
really cool. It's sort of like last year when we were watching Jupiter and Venus real close to each other at the end of June. Do you remember that?
Yeah.
Like we were on those travels. Yeah, they were real close to each other, and then they kind of separate, and then they ended up coming back together again at the end of August. I think they were real close to each other again.
I think so.
Real strange how that works. But yeah, you kind of see how they're not really all moving the same way at the same rate. They kind of like flux away from each other and then back toward each other, sort of with the independent motions of those two bodies, and then our body as a planet moving around the sun. They kind of move in a separate synchronization with each other. So they just kind of float around in the sky. It's really strange to see.
Yeah, it's really strange to observe.
Yeah.
Because I don't think, well, speaking for myself, I don't think of them moving like that.
Right. Yeah. And
so it's really strange to see how they are around each other. It kind of helps you understand, or maybe it just makes it more confusing.
And then now try and understand that that's not an independent motion that's just happening now, but that's a cyclical motion that's going to repeat itself exactly at some period in the future. And that has to be tracked, or has to be figured out over decades to sort of get a handle on how that rhythm of things work on the earth. It's a lot of stuff to kind of comprehend and accurately try and demonstrate or understand. It's amazing that anybody beforehand was able to do it as well. I mean, I'm interested in it, and only I don't know that much about it. I can barely keep track of how long the planetary cycles are.
Yeah, I was thinking about that during our last podcast, or just like how you discover that.
Oh gosh.
Like when you're in those, or like in the earlier times, like how did we figure out those cycles, like the Saros cycle? Because it's so much time.
It's so long. Yeah.
How do you notice
it's 53
that
years before it would really be observable in the same spot. I guess lunar eclipses might be a little bit more accurate to detect in that way, but
really interesting.
Really interesting. And that's Babylonians. That's I don't even really know. I don't know. That's way back. That's a long time ago. I think it's like 700 BC. Those are sort of the dates that I was looking at for a lot of the pieces here, which is really, I mean, gosh, that's almost a millennia before like Hipparchus was doing a lot of stuff. I mean, I think that was 300 BC era. I think that's like the Hipparchus era, which was a lot of stuff that was kind of left over from the Babylonian astronomy. I think it's sort of this weird kind of transition of who's translated what over time to get it to where it is now. But yeah, I think a lot of that early cycle stuff was put down by the Babylonians. Real strange. We got to look into it more. It'd be real fun though. I like that ethno astronomy side of stuff.
Me too. It's really interesting.
Yeah, to think about how ancient people try to comprehend and evaluate the stars. But it's interesting too because it seems like there was a lot of thought put into that, at least by the astronomer class of the day. I guess the astronomer class of our day does the same thing, but with the average person or with most experiences you have with people, no one really knows where to go anywhere in the sky, which is it's an interesting thing that there's so many people even right now that don't know the cycle of an eclipse or something, but someone was able to count that out over years and years and figure it out almost 3,000 years ago. It's really strange. Or it's just amazing to think like, wow, they like had that much depth into it because they probably were thinking about it wrong for a long time before that, before they figured it out. So it's just strange how they can kind of move stuff forward like that. But even for a long time, they were still thinking about it wrong. They thought that the stars were fixed positions that themselves would move around our fixed body of the Earth. Oh. And that's like a recent thing. That's like the heliocentric world or like the idea that the Earth is turning. That was a long time before anybody figured out that the Earth could be rotating. And that's why we see stuff move around us. Real strange. But I'm not sure about that though. I think that was a conflicted thing even before the establishment of the church and the ethnocentric, the earth-centric, the geocentric, I don't know. What would it be, like orbital cycle or something? Like the idea that the Earth's at the center and that everything kind of rotates around it was dominant before, but I got to think that there was dissent. Otherwise, I don't think they would have been able to cleverly track how everything moves, the way that they do. There's that other thing I was looking at of like the cycles of the planets, a little bit of what we were talking about a minute ago, like how Venus has an 8-year cycle, then it starts to repeat its motions again.
Right.
Like, it's really strange how that'll be. Like Jupiter has, I think, a 12-year cycle. Maybe it has to do with their rotation or their orbital period around the sun, because that kind of seems to be part of it. With Venus, it's a little different because the Venus's orbital period is like 87 days or something. It's not very long. It's less. Was it 200 days? Ah, man, I don't want to remember anything. I took a high school astronomy class. I'm not sure. but Venus has a shorter year than the Earth does, right? But it has an 8-year planetary cycle, an 8-year cycle for the Earth, the Sun, and Venus to be in about the same position at about the same time again. But there is a cycle to it. It's an 8-year cycle, but it's way longer. That's like 10 to 11, 12, 13 years on Venus, which is just really strange that there's kind of that the motion of those bodies repeats itself in a cyclical way, the way that it does. Still something that I can't really wrap my head around. I can't remember the last time. I don't remember the last 2 cycles that I lived through of Venus's motion. I kind of been tracking like the Jupiter one. That's kind of been cool. So now it's in Leo. I remember back in like 2007 when it was in Scorpio. I remember before that when it was a little bit before that, or further back from that. So it's cool to get to see, I suppose. But yeah, it's strange, but it just comes up a little later each year. So now it came up at opposition at sunset in like, what was it, March? Yeah. Wow. That's crazy. It's weird how just everything kind of moves around. But it's pretty cool though. I'm glad that we're getting to like keep an eye on it. Oh, there's that other thing I was going to talk about. The seasonal stars. I thought that was a cool thing. I don't know. I haven't really put much effort into the research side of it, but I do know like there's like a set of stars. There seems to be 4. These are the 4 that I account for often, but I mean, everybody's accounted for these for a long time. I've heard them come up before and other things, but there's like the seasonal stars that kind of, it's the bright star that's coming up at the time when that season is beginning. So for the winter at the beginning of the year, we'd have Sirius start coming up right at the first of the year almost, is when we start seeing Sirius come up and rise into the southern sky, but rise from the east and come up into the sky. For from March into March and then into the spring and summer, what we start seeing is the star Arcturus start rising from the east, which is sort of a signifier that spring is coming, that it's one of the bright stars that's coming up from the eastern horizon as spring starts to set on. And as Sirius starts to set, if you start noticing Orion and Sirius and all that, that's getting quite a bit closer to the edge of the horizon. In fact, it's really a bit more difficult to start making observations of Orion at this time of year from April on. I think you get like another 2, 3, 4 weeks of that. And then it's real difficult. You got to be right out at sunset to make observations of it because it just starts hitting twilight and then it's almost out of observation, but it's up in the sky for maybe a month or so and then it's gone. You just don't get to see it unless you're right out on the trigger of it. But the seasonal stars, as Orion sets, as Sirius starts to set, we see Arcturus come up in the sky as a spring star. For the summer, we see Vega, like how we'd seen in the summer before, Vega, the summer triangle that we observed, the Vega, Deneb, and Altair that's out there. Do you remember that from like the stuff from the past?
Yeah,
go out and look at it. Yeah, and Deneb. Yeah, I remember going out and hanging out with you in the back of the truck. We had the top off the truck, the Forerunner. That was fun camping out, and then like hanging out and making cool little observations, trying to figure out, name the stars. That was fun.
Quizzes.
And so we have Vega in the summer as a pretty predominant first magnitude stars that passes over, rises from the northeast. And then in the fall, one of the most dominant ones that I've always taken a lot of note of that I think is interesting is it rises right as October, as September, as that seasonal change is coming, is the star Capella, which is one of the fall stars. So we have Arcturus right now rising up as the spring star, and then Vega for the summer, and then Capella for the fall, all kind of rising up in the same sort of general location of like due east to northeast as they come up. But yeah, it's kind of a cool little seasonal indicator that's also been mentioned and kind of earmarked in the past before. There's lots of historical background to different synchronizations between like this star coming up and the onset of this season.
It's really cool.
Yeah, like we talked about. So we're in like a 4-season climate. So our culture kind of notes those 4 separate seasons, but in other places where it's really just like a dry and rainy season, then they have different marks for when different things start. Like I think in Egypt, maybe we talked about like the alignment of, I think, Sirius and the sun in the summertime. So like Sirius is up right now in the wintertime. And I think the end of July or so, that's when Sirius and the sun are going to be rising at the same time. And so it was sort of thought that when that happens, that's when the flooding of the Nile is going to happen in ancient Egypt. And so they have this kind of indication that when Sirius and the sun get to the same point together, that's going to be the flood. That's going to be when we have to deal with all of our agricultural stuff that we're going to deal with, which is really strange. Or like when the rains would come and then the flooding would happen. And
yeah,
then
it's interesting.
Yeah, everything they'd work out. But they wouldn't have the same kind of year indicator that we would work with in our 4-season climate.
Yeah, that's interesting.
Yeah, it's cool. It's kind of cool to think about, I don't know, different stars and
how they match up with the seasons.
Seasonal parts of it. But yeah, I think it's just about everything that I had to talk about. Did you have any other ideas for our little podcast stuff?
I think we
probably covered a lot of it. Yeah. I think it's been pretty fun talking with you guys. We're talking to the audience and talking with you, Marina. Oh, audience guys, I appreciate it if you guys would, subscribe to the podcast. I won't say rate and review it yet. Let us kick through a few more burner episodes before you try and recommend it to too many folks who probably wouldn't be too amazed by it. But we're going to do our best and try and do quite a few more podcasts coming up here in the near future. More stuff about the night sky and stars above us. So yeah, help us out. Subscribe to the podcast if you can, and definitely check us out next time. I think we got a couple other cool events coming up. We're going to do a lot of observations. That's, I think, a big focus that we're going to work on a little bit is grabbing the telescope, jumping out, and just doing natural observations too, like no telescope required sort of stuff. That's the most fun. We should go out on a walk a little bit. Take a peek at Jupiter.
Let's check out Jupiter.
See some constellations. That'll be fun. I guess you guys should do the same too if you got clear skies where you're at. And on behalf of Marina Hanson, my name is Billy Newman, and thank you very much for listening to this episode of the Night Sky Podcast.